Hello viewers, welcome back to my channel Zero Web. This is me Rikilas Ritesh. In this video we are going to study about the quadrilaterals in detail. The word quadrilateral derived from two Latin words. Quadrilaterals derived from two Latin words, quadri and latus. Quadri means 4 and latus means sides. Therefore, quadrilateral is a polygon with the 4 sides, right? And we have seen some facts about quadrilaterals in the previous videos. So, which are they? If we are considering a quadrilateral ABCD, what are the adjacent sides, adjacent vertices and diagonals? So adjacent sides are the sides which meets at the same vertex, right? So here we can say AB and AD are the adjacent sides. Why? The sides AB and the side AD or DA meeting at the vertex A. And we can say AB and the CB are adjacent sides. That is, these two sides meeting at the vertex B. CB and DC are the adjacent sides. They are meeting at the vertex C. CD and AD are the adjacent sides. They are meeting at the vertex D. Right? So adjacent sides are the sides which are meeting at the same vertex. And which are the adjacent vertices? Here A and B are the adjacent vertices. Why? That is, these two vertices are the endpoints of the side AB, right? And here B and C are the adjacent vertices because these are the endpoints of the side BC. And C and D are the adjacent vertices. These are the endpoints of side CD. And D and A are the adjacent vertices. These are the endpoints of the side DA. Okay, so adjacent vertices are the vertices which are the endpoints of the same side. Okay, and which are the non-adjacent vertices of this quadrilateral? Here B and D are the non-adjacent vertices and A and C are the non-adjacent vertices. So diagonal of a polygon is the line segment connecting any two non-adjacent vertices, right? So here if we are connecting A and C, then we can form a diagonal. Similarly, if we are connecting B and D, we can form a diagonal. So AC and BD are diagonals of this quadrilateral ABCD. And we have seen the formula for finding the number of diagonals of any polygon, right? If n is the number of sides of a polygon, then we can find the number of diagonals of a polygon by n into n minus 3 divided by 2. Just to substitute the value for n here, then what will you get? It would be, that is the quadrilateral having 4 sides. So 4 into 4 minus 3 by 2, that is equal to 4 into 1 by 2, that is equal to 2. That is 2 diagonals a quadrilateral have. That is what we got here, right? AC and BD are the diagonals of the quadrilateral ABCD. Now we will move on to the angles and property of a quadrilateral. Angles and property of a polygon says the sum of interior angles of a polygon is always n minus 2 into 180 degree. So in the case of a quadrilateral, what we can say? That is 4 minus 2 into 180 degree. That is 2 into 180 degree. It is equal to 360 degree. Right? So angles and property of a quadrilateral says the sum of the interior angles of this quadrilateral should be 360 degrees. So we can say angle A plus angle B plus angle C plus angle D equal to 360 degree. Clear? Then what about the exterior angle property of a polygon? Exterior angle property of a polygon says the sum of all exterior angles of a polygon should be always 360 degree. Even if it is a triangle, quadrilateral, pentagon, any polygon, sum of exterior angles should be 360 degree. We are extending this side AB, then this angle is an exterior angle, and if we are extending BC, this is an exterior angle. If we are extending this is again an exterior angle, and if we are extending AD, then this again form an exterior angle. If we are naming this exterior angles as 1, 2, 3, 4, then by exterior angle property of a quadrilateral, we can say angle 1 plus angle 2 plus angle 3 plus angle 4 equal to 360 degree. Okay, so these are the facts we have seen in the previous videos. Based on the special characteristics of sides and angles, the quadrilaterals are of mainly three kinds: trapezium, kite, parallelogram. Okay, now we can say different kinds of quadrilaterals. So quadrilaterals are mainly classified into three types, that is trapezium, kite, parallelogram, right? And this parallelogram again classified into rhombus, square and a rectangle. We have quadrilateral, a polygon having four sides, and all these figures are having four sides, right? So first one, trapezium. Trapezium is a quadrilateral in which one pair of opposite sides are parallel, and kite, the two pairs of adjacent sides are equal, and in parallelogram two pairs of opposite sides are parallel, that is these two sides are parallel and these two sides are parallel, that is in a parallelogram two pairs of opposite sides are parallel. And basically there are three types of special parallelograms. One is rhombus, square and a rectangle. Okay, and this square and rectangular basic quadrilaterals you have been studying in your lower classes, right? Now we will see each type of quadrilaterals in detail one by one. First quadrilateral is trapezium, and its properties are given here. First property is at least one pair of opposite sides are parallel. Here if we are considering the first trapezium, we are naming it as ABCD. Then here we can see that AB parallel to DC, right? AB parallel to DC. But here we cannot say AD and the BC are parallel. So at least one pair of opposite sides should be parallel. Here if we are naming it as ABCD, then again we can say AB and the DC are parallel. If we are naming it as LMNO, then we can say LO is parallel to MN, and if we are naming it as RING, in this trapezium RI is parallel to GN. Clear? So first one is clear. At least one pair of sides are parallel. So here these two are not parallel, these two AD and the CB are not parallel. Here ON and LM are not parallel. RG and NI or IN are not parallel. Then second one, non-parallel sides can be equal or unequal. Okay, here non-parallel sides are these two. These are not equal. If we are taking this AD as 4 centimeter and BC, length of BC as 4 centimeter, then we can say AD equal to BC. Then these type of trapezium are known as isosceles trapezium. Clear? It is given that is, this is known as isosceles trapezium when two non-parallel sides are equal. This may be equal or unequal, but whenever this non-parallel sides are equal, then we can say that this is an isosceles trapezium. Okay, and next property, diagonals intersect each other. If we are considering a diagonal, we have in a quadrilateral there are two diagonals. So these diagonals intersects each other, right? If we are considering diagonal here, then that also intersect each other, right? And next property, two pairs of adjacent angles add up to 180 degree. Okay, if we are considering a trapezium ABCD, name it as ABCD. Here AB parallel to DC. Okay, and if I am naming the interior angles as 1, 2, 3 and 4. If we are extending the side AB and the side CD, this AD acts as a transversal, right? This AD will act as a transversal. Similarly, the CD will act as a transversal. So we have, if a transversal intersects or cross two parallel lines, then this angles on the same side of the transversal are supplementary. That is, those angles add up to 180 degree. Here, these two angles, angle 1 and angle 4, are in the same side of the transversal AD. So we can say angle 1 plus angle 4 equal to 180 degree. Similarly, this side BC act as a transversal. So we can say that the angles on the same side of the transversal CB are supplementary, or that is add up to 180 degree. Therefore, angle 2 plus angle 3 equal to 180 degree. Clear? Therefore, we can say two pairs of adjacent angles. These are adjacent angles, right? Two pairs of adjacent angles add up to 180 degree. Clear? So these are the 5 properties of trapezium. Okay, now we move on to the second kind of quadrilateral, that is kite. So these are the examples for kite. Here it is given, the first property is two distinct adjacent pairs of sides are equal. So in this figure, in this kite ABCD, we can see AD equal to CD, right? And AB equal to CB. So these two sides are equal and these two sides are equal. Similarly, in this figure, we can say RG equal to RI and GN equal to IN. Okay, that is, these two sides are equal, but here these two sides are not equal. These are adjacent sides. AD and AB are adjacent, though they are not equal. These two are adjacent, but these two are equal. That's why it is given that two distinct adjacent pairs of sides are equal. Though these two are adjacent sides, these are not equal, but these two adjacent sides are equal. Clear? And second property is only one pair of angles are equal. It says that the angle between two unequal sides are equal. See, these two angles are equal. That is, angle A equal to angle C. Similarly, in this figure, which are the unequal sides? That is RG and the GN. So the angle between the unequal sides, or angle included between the unequal sides, here angle G and angle I are equal. Okay, we can prove this second property with the help of this figure. Okay, this is a quadrilateral ABCD. Here A and C are non-adjacent vertices, so that we can form a diagonal AC, right? So this diagonal AC divide this quadrilateral into two triangles. Which are they? Triangle ADC and triangle ABC, right? Now, if we are considering the triangle ADC, you can see here AD equal to CD. In this triangle we can see AD equal to CD. So this is an isosceles triangle, isn't it? So that we can say this is an isosceles triangle, right? So that we can say in an isosceles triangle the base angles are equal, right? If we are considering this base angles of this triangle are angle 1 and angle 2, then we can say angle 1 equal to angle 2 using the properties of isosceles triangle. Okay, and if we are considering this triangle ABC, this is also an isosceles triangle. Why? It is given that AB equal to CB. AB equal to CB. So these two sides are equal. So we can say that it is again an isosceles triangle. Right? And if we are considering its base angles as 3 and 4, then we can say angle 3 equal to angle 4, isn't it? And if we are considering this angle combinedly, then we can say that angle 1 plus angle 3 equal to angle 2 plus angle 4. Right? Angle 1 plus angle 3 is angle 1 is angle 2 and angle 3 is equal to angle 4. Right? And if we are combinedly considering these two angles, angle 1 plus angle 3 is some angle A, small letter angle A. And if we are combinedly considering these two angles, angle 2 and angle 4 as small letter angle C, then we can say angle A equal to angle C. That is angle A equal to angle C. Clear? So these two angles should be always equal in a kite. Here we can say angle G equal to angle I. Right? That is the angle included between two unequal sides should be always equal. Clear? Now we will move on to the third property. One diagonal bisect the other at a right angle. That is two diagonal. We have in a quadrilateral there are two diagonals, right? Here we have considered one diagonal, that is AC, right? And which is the other diagonal? Okay, AC is one of the diagonal, and if we are considering another diagonal, because B and D are non-adjacent vertices, so we can consider another diagonal. Then we can say one diagonal, that is BD bisect AC. Bisect means it divides, the diagonal BD divides the diagonal AC into two equal parts, right? These two length would be equal. Clear? So how can we prove this? Let's see. Okay, here AC is one of the diagonal of this quadrilateral ABCD, and this AC divide the whole quadrilateral ABCD into two triangles. If we are considering only the triangle ACD, this is triangle ACD. Here these two sides are equal and this is the base. Okay. And if we are considering the perpendicular bisector of an isosceles triangle, it will divide the base into two equal halves. That is, this perpendicular bisector divides this base AC into two equal halves or two equal parts, right? and this will form a right angle here with the base AC. Clear? And if we are considering this triangle ABC by keeping the base as AC downward, okay, then this vertex is B. Okay, now we got AB, CD. Here this AB and CB are equal sides, right? The triangle ABC is again an isosceles triangle. So if we are constructing a perpendicular bisector of this triangle ABC, then it will bisect this diagonal AC into two equal parts, right? So these two perpendicular bisectors intersect at the point O, right? That is, in both case AO equal to OC. Both these perpendicular bisectors divide this AC into two equal parts, right? But here OB not equal to OD, right? So that's why we can say only one diagonal, the BD bisect the other diagonal AC into two halves, two parts. That is, we can say diagonal BD bisects diagonal AC at a right angle. So these are the three properties of kite. So first one is two distinct adjacent pairs of sides are equal and only one pair of angles are equal. That is angle A equal to angle C, and one diagonal bisect the other at a right angle. That is diagonal BD bisects the diagonal AC. Clear?